This is section 1.2. It's the introduction to limits. It can be used for either the honors calculus right now or AP calculus. All right, so we're going to talk about the concept of a limit. So first of all, let's look on our graphing calculator and see if we can sketch this graph. And we're just going to go to the graph screen, and we're going to use this for our window. The x, we're going to go from -3 to 3, and the y, we'll have it go from 0 to 5. Okay, so on my calculator, go to your y equals, and you do need to practice this because you're going to be graphing on your calculator. I'm going to put in a fraction, so alpha y equals, and then choose number 1. Okay. And then on the top, I want x cubed, so x to the third. And on the bottom, oops, I forgot my -1, sorry. -1. And on the bottom, I just want x minus 1. And we said we're going to set the window from -3 to 3. And I'll leave the scale to be 1. And I forgot what the y is, 0 to 5 for the y. Let's see, so for the y, 0 to 5. And again, I'll leave the scale to be 1. So when I graph it, looks something like this. So let's see, it's kind of like a parabola. It has a space in the graph over there. So let's see if we'll just kind of draw it the best we can. Let's see, the space was kind of like right in here, something like that. It looks like it went through this point, kind of came down here somewhere. I don't know, something like this. Okay, this is kind of a sorry parabola. Sorry about that. Oh my, I'm having a terrible time. Okay, that's the best it's going to get. But remember, we had kind of like this space right in here. Okay, so let's look at the questions. Evaluate the following, f of -1. So kind of like we said last time, I could look on the graph at -1, but I don't know how accurately I've drawn this graph. So let's use the equation. If I put in -1, let's see, on the top, I'm going to have -1 cubed is -1 minus 1. And on the bottom, I'm going to have -1 minus 1. So -2 over -2 equals 1. And that kind of makes sense because at -1, it seems like maybe the y value might be 1, kind of accurate. Okay, what about +1? If I put in a +1, I'm going to have 1 cubed minus 1 all over 1 minus 1. Well, that equals 0 over 0, which does not equal 0. It's undefined. And it's not the 0 on top that's the problem. It's the 0 on bottom. Okay? So what is happening on the graph at x equals 1? Well, look at the graph. When x equals 1, right there is where you had that space in the graph, right? You have a hole in the graph. Okay, so the question we want to ask is, in calculus, is, yeah, there's a hole there, and we talked about that back in Algebra 2 and Pre-Calculus, but what if there was a y value there? What if there was a y value? Okay, if there was a y value, it looks like it would be y equals 2-ish, right? Well, that's what limits are about. It's kind of like predicting a y value, whether there's an actual point there or not. So even though there was a hole and there's not a point there, I could predict that if there were a point there, that even though x is 1, the y value would probably be 2. Okay, and so the way we write that, the notation for a limit is, we would say, in this case, we would say the limit, and we just abbreviate LIM, and then underneath we're going to, because we wanted to look at the limit when x equals 1, so we're going to say as x approaches 1, so I'm reading it as I'm writing it. The limit as x approaches 1 of this function, and this function was x cubed minus 1 over x minus 1. So the limit as x approaches 1 of this function equals, so the answer to the limit is the predicted y value, whether there's a hole or not. And in this case, the predicted y value there would have been 2. Okay, so let's look at example 2. It says evaluate the limit. So I want the limit as x approaches 0. So I'm going to graph this function, And I'm going to see what's happening right there at x equals 0. Okay, so I'm going to graph, go back to my y equals. I have a fraction, and let's see here. On the top, I just have x. On the bottom, I have square root of x minus 1. And make sure you move the cursor out from under the square root. Oh, that was supposed to be a plus 1. So on the outside, it's a minus 1. I'm going to move the cursor back over. On the inside, it was a plus 1. Sorry about that. And they don't tell me anything about a window, so I won't worry about a window, except that I want to look right there at the x-axis and see what's happening. Why? I should say x and y-axis. Why? Because it says as x approaches 0. So I'm just going to go back and do like a zoom 4 for just a basic window. Okay, so when x equals 0, it looks like the graph goes through and has a y value of 2. Does it actually have a point there? I don't see any spaces, but what if I do this? If I were to trace, and see how down at the bottom it says x equals 0, you notice that for the y, it doesn't give me a specific value. So that means there is a space there. It's just that we can't see it. It's kind of like the y-axis is kind of going through that space. In fact, I'm going to show you something. What if I were to take off the y-axis? Just curious. Let's see. If I were to take, can I take those axes off? Well, let's do this. See this? Oh, that's the grid. Here we go. Axes, right now, they're black. Wonder if I can get rid of them. Oh, there we go. Axes off. Okay, so axes off, enter, graph. Look, do you see that space where the y-axis would have been? There's a space. So I couldn't see the space because the y-axis was going through there. I'm going to turn those axes back on. Let's see. Axes. I don't know what color do I want them to be. I will leave them black. Okay. So we said the predicted y value, if there was a point there, the predicted y value would be 2. Okay. Now let's look at limits that fail to exist. So in other words, can you always predict the y value, or is it possible that the limit doesn't exist? Okay, so let's look at this graph. It says we want to graph, let's see, a fraction, and on top I just want x minus 1. On bottom I want absolute value, so I'm going to say alpha window and choose number 1, absolute value of x minus 1. It just says sketch it. I'll just go back and say graph. Oh, look, it's kind of like a horizontal line down at -1 and then a horizontal line up there at +1. So it's going to look something like this. Horizontal line here and then horizontal line up here. Okay. So when approaching x equals 1 from the left. All right. So right here is where x equals 1. I've got my my graph is off a little bit. That kind of stopped right there. Okay, so as I'm approaching x equals 1 from the left, so I'm coming in from the left right here towards where x equals 1, the y values go to, well, what's the y value down here? Isn't the y value -1? But as I approach x equals 1 from the right, so as I'm coming in from the right side towards x equals 1, aren't the y values right there going towards +1? So do you see that I can't really predict what the y value would be at 1, because from one side, it's going towards -1. From the other side, it's going towards 1. I can't tell where those graphs are going to meet. And I don't want to just average them because, I mean, I'm not going to assume that the graphs just, go straight down and connect. I don't know that that happens. I mean, have you ever seen a graph do that? So I can't predict what the actual y value is at 1. So we would say the limit as x approaches 1 of this function does not exist, okay? Because the two sides don't come together at the same y value, okay? So number 2, let's look at this function. Well, you could put this on your calculator if you want, but I can tell you what this is going to be. There's going to be a vertical asymptote at 1 because of that x minus 1. There's a horizontal on the y-axis, because if you remember your Bobobot and stuff. And then when you draw your graph, you're going to have these two pieces, but they're both going to be up here. So you can put it in your calculator if you want. I don't expect you to know that graph. I'm telling you, saving us the time and effort. Okay, something like that. So this one says, when approaching x equals 1 from the left. Okay, so as I hop on this graph and I start going towards where x equals 1, yeah, I know it's an asymptote, but I don't know I can't really predict. It looks like the graph is shooting straight up, so the y values are going towards infinity, right? And as I'm coming in from the right side towards that asymptote, towards x equals 1, again, aren't the y values shooting up to infinity? So if we want, we could say the limit as x approaches 1 of this particular function, 1 over x minus 1 squared, we could say, because both sides are going to infinity, then that makes us know that at 1, really the graphs are going towards infinity. So we could say infinity, but I want you to understand that's not a specific number. I mean, that's not a concrete number that we can give as a y value. So I really can't predict the y value. I mean, I might ask one person, what does infinity mean? And they might say 300 billion. I might ask someone else, what does infinity mean? And they'd say, I don't know, 2 trillion. Okay, so infinity is not always equal. So even though we can say infinity, what we really mean is that the limit does not exist. Okay, so let's kind of put a summary here. There's 2 ways that a limit doesn't exist. The first way is that the left does not equal the right. In other words, the left side of the graph does not meet up with the right side of the graph. And the second way is if you have a vertical asymptote. Because if there's a vertical asymptote, you are going to have unbounded behavior. What I mean by unbounded, meaning it's going to shoot up to infinity or it's going to shoot down to negative infinity. Unbounded behavior on the graph. Okay, so if you have a vertical asymptote at a particular number, then we would say the limit doesn't exist there. Or if the two sides of the graph don't meet, we would say the limit does not exist there. So when I look at these examples, and you can tell these kind of came out of a textbook, but I think it's worth us trying them together. So look at the first one, they're calling number 9. You can either look at the equation or you can look at the graph. So the limit as x approaches 3. So at x equals 3, there is actually a point there. Okay, what's the y value? The y value is 1. So if there's an actual point there, then the answer to the limit is just the y value. Number 10, notice it says as x approaches 1. So at x equals 1, the y value right there is 3. Okay. On number 11, I'm trying to find the limit as x approaches 2. Okay, so if I look at the graph, at x equals 2, on the graph there's a hole. But do you see that from the left side, I get the same thing as I have from the right side. So it's okay that there's a hole. The predicted y value when x equals 2 is 2. That's where the two sides of the graph come together. Okay, you might be saying, well, what about this point down here? Okay, that's a point that's dropped out. When we're talking about a limit, we're talking about the two sides of the graph coming together. So on number 12, this one says the limit as x approaches 1. So at x equals 1, the two sides of the graph come together at a hole, but the y value of that hole would be 3. Okay, it does not matter that there's this point dropped out down here. Now, I will point out, if I said, what is the value of f of 1? I'm not asking about the limit. I'm just saying, when x equals 1, what is the actual y value? Well, the actual y value really is coming from that point. The y value is 1. So that's not the limit. The limit is where the two sides of the graph come together. Okay? Over here on number 11, the limit as x approaches 0 is, as x approaches 2 is 2. But I could have said, what is the value of f of 2? And we would have said, well, what is the actual y value when x equals 2? Well, the actual y value is 0, because that point, where the actual point is at 2, 0. Okay? Number 13, this one says the limit as x approaches 5. Well, do you see, whoops, sorry about that. Do you see that at 5, the left side does not equal the right side? So we would say does not exist. On number 14, I'm looking for the limit as x approaches 3. Well, do you see that there's a vertical asymptote where x equals 3? So we would say does not exist. On this one, I can't say infinity or negative infinity because one side goes to infinity, the other side goes to negative. So I can't really say one or the other. I just have to say does not exist. Okay, on number 15, the limit as x approaches 1. Well, at 1, there's an actual point there, and that is where the two sides of the graph come together, so the y value is 0. And on number 16, the limit as x approaches 0, the y value right here is 1. Okay, so let's look at kind of different kinds of notation. This is bringing together what I was kind of trying to point out earlier. Okay, so this is my graph of f of x. The limit as x approaches negative 3. Okay, well, that's where that red vertical asymptote is, so automatically I can say does not exist. Okay, but it says what is f of negative 3? In other words, what is the actual ordered pair at negative 3? Well, there's not an ordered pair. There's not an actual point at negative 3. So the only thing is for limits, we usually say does not exist. If we're talking about points, we usually say they're undefined, meaning there's not a point. It's just notation, okay? Number 3, the limit as x approaches negative 1. Well, at negative 1, the two sides of the graph actually come together at that point, and the y value is 0. What is f of negative 1? Well, since there is actually a point there, the y value is 0. So sometimes the actual point is the same as the limit. What about the limit as x approaches 1? Well, here's where x equals 1. Even though there's a hole, that's fine. The left side of the graph comes together at the right side of the graph, and the predicted y value would be 2. But number 6 says, what is the actual point at x equals 1? Because that's not an actual point, and there isn't an actual point anywhere, dropped out. I see no ordered pairs, actual points where x equals 1, so I'm going to say undefined. Okay, number 7, what about the limit as x approaches 4? Well, the limit, do you see that the left side goes up here, the right side goes down here? Those two sides do not meet, so my limit does not exist. Okay, what about f of 4? Well, where is the actual point? Not here, this is the hole. But there is an actual point right here, so if x equals 4, the actual y value is 3. So if you're watching this for AP Calculus, that's kind of the end of the notes for them. But if you're sticking with Honors Calculus, we're going to go on and talk about one more concept, and it's called one-sided limits. And we've kind of been talking about it, we just didn't really give it notation yet. Okay? So this one says, look at this graph. We're going to call this f of x. This is going to be our graph of f of x. It says the limit as x approaches 0. Well, what we've said before was, hey, coming in from this side, I go down to negative 4. Coming in from this side, I go down to 0. So they don't come together. So I'm going to say that limit does not exist. Okay? And so go on to read. It says, because x approaches 0 from the right, so as I'm coming in from the right side towards x equals 0, as x approaches 0 from the right, the y values go to this point, and that y value is 0. Okay, but as x approaches 0 from the left, so as I go towards where x equals 0 from the left side, the y values go to, even though it's a hole, the y values are headed for negative 4. I don't know why that got all ugly. So the way we would write this notation is, even though the limit as x approaches 0 overall does not exist, the way to write this is to say the limit as x approaches 0, and from the right we put kind of like a little plus sign. It's kind of like an exponent of a plus sign. So that means as x approaches 0 from the right, and I'm going to say of this function. So we said coming from the right, the y values go to 0, and then we said coming from the left, the y values go to negative 4. So the limit as x approaches 0 from the left, that's like a little negative sign of this function, those go to negative 4. And it's the fact that one side goes to 0 and one side goes to negative 4. It's the fact that those are not the same number. That's why we would say the overall limit does not exist, because those two sides don't go to the same number. Okay, so it's just kind of a notation thing. So let's look at an example. It says, sketch the graph of the piecewise function. Okay, so let's just do the best we can. I have the 1 over x graph when x is less than 0. Well, remember the 1 over x graph has the piece up here and the piece down here. But if I only want the part when x is less than 0, I only want this part of that graph. Okay, and then the other side, I want the line x plus 1. Here's my y-intercept of 1, a slope of 1. I only want that part on the right, so that's going to be kind of that line over there. Okay, so look at to the left. It says evaluate the limit as x approaches 0 from the left. Well, as I'm coming in from the left, do you see that's where the graph is shooting straight down? So I'm going to say that, well, that goes to negative infinity. It's true, we could say does not exist, because infinity really is a does not exist, but it's kind of like we're saying the limit does not exist, and the reason it does not exist is because it's shooting down towards negative infinity. So negative infinity is a more specific answer than does not exist. Okay, what about on the other side? The limit as x approaches 0 from the right. Well, as I'm going towards x equals 0, from the right side, that y value is going towards 1. Okay, example 2, evaluate the limits below. So on these, we need to think about what does the graph look like? Okay, so let's see. What does the graph look like? Let's do some factoring and simplifying and see what happens. Okay, so I think of this as I've got my 2 minus x. Wouldn't this be like an x plus 2 and an x minus 2? And I can see that x minus 2 cancels with 2 minus x, and then just leave negative 1. So the actual function that I'm looking at here is the limit. We're looking as x approaches negative 2 from the left, and what we're looking at is the graph of negative 1 over x plus 2. Well, isn't that just the 1 over x graph moved 2 units to the left? And if it's a negative out in front, it's flipped, so it's going this direction, something like that. Okay, so what's the limit as x approaches negative 2 from the left? Well, from the left, this is going towards positive infinity. Notice letter, if I had said from the right, I could have said negative infinity. Notice letter B. Isn't that the exact same graph? Right, 2 minus that. Okay, so let's look at the exact same graph. What about the limit as x approaches positive 2? Well, wait a minute. Positive 2 is over here somewhere, right? So it's kind of hard to tell. I mean, the way I have it drawn, it kind of looks like 0. But how can I know for sure what that y value would be? Well, let's plug in 2. Let's plug in x equals 2 into our simplified version of the equation. If I did that, I'm going to have negative 1 over 2 plus 2. So the actual y value right there is negative 1/4. So it's actually just below that y-axis. Okay, so let's look at number 1. Well, let's see if we can think about the graph. Will this simplify? Yeah, I'm going to have 3 minus x over x plus 3. It looks like this is going to be very similar to the last thing we did, right? Those are going to cancel, so really I just have negative 1 over x plus 3. So I've got this 1 over x graph, 3 units to the left, and it's a negative, so it's going to be here and here, right? Okay, so look at the question. It says, what's the limit as x approaches positive 3? The limit as x approaches positive 3. In this case, if I plug in a 3, I'm going to have negative 1 over 6. So that means over here at positive 3, let me put it in different colors, you can see better. Over here at positive 3, the y value is going to be approximately negative 1/6. Okay? Now notice number 2, what's the difference? Well, the top is different. So even though I have the 3 plus x, the factors on the bottom are still x plus 3, x minus 3. So how is this graph going to be different? Well, if this is just 1 over x minus 3, first of all, it's the 1 over x graph, but it's not flipped, right? So here's my asymptote. I've got my 1 over x graph. Okay, that's kind of looks like it goes below the y-axis, and it doesn't. So something like this. And this one says, what's the limit as x approaches positive 3 from the left? Well, look here. Positive 3 is where my vertical asymptote is. So yeah, I know this is a does not exist. But since they said from the left, then I can say, well, from the left, it's shooting down to negative infinity. So negative infinity is the specific answer. Does not exist is the general answer. Okay, notice that the equation from number 2 is exactly the same as the equation from number 3. So I'm looking at that same graph, but this time number 3 says, what about x approaches 3 from the right? Well, as I come in from the right, yeah, it's still a does not exist. But if I want a specific answer, I could say positive infinity. Okay. Again, we're looking at the same graph. Number 4 says, what if I just say the limit as x approaches 3? Well, I can't say positive because that's only the right, and I can't say negative because that's only the left. So all I can say on this one is that it just does not exist. Okay? So that would be section 1.2.